motor proteins know when, where, and what cargo to pick up, and when, where, and what cargo to drop off? Modern biology and microscopes give us an answer. Motor proteins don't know, but instead rely on Brownian motion, adapter proteins, and receptor or sensor proteins on or in the cargo itself. Brownian motion is the haphazard motion of matter consisting of particles due to their inherent energy levels. Many motor proteins float around in the cytosol and then collide with adapter proteins. If the adapter is active or binded to cargo and compatible with the motor protein, the adapter binds to the motor protein and activates it. Imagine a trailer tether. The transport complex then, if it has not already, detaches from whatever organelle it is attached to, like the ER or the Golgi complex, which are cargo packaging and shipping factories in the cell. Eventually, the motor protein with its trailer collides again with one of the many cytoskeleton tracts in the cell and begins the ATP walk. If the motor protein is kinesin, it walks towards the exterior of the cell. If it is dynein, the motor protein walks to the center of the cell. If it is myosin, it walks around the perimeter of the cell. Sometimes a cargo has binded to multiple adapters, or an adapter has binded to multiple motor proteins for ease of back and forth motion, expedited movement through the cell, and redundancy in motion. Receptor or sensor proteins in or on the cargo's membrane are aware of the environment biochemically and influence the recruitment decisions of the adapters and change states as the cargo journeys around the cell, triggering the adapter proteins to release and engage motor proteins as required. When certain environmental conditions are met, again, the receptor or sensor proteins change states, triggering the adapter protein to release both the motor protein and the cargo. The destination has been reached. The cargo passed off, and the former adapter and motor proteins made inactive for the time being, which float around now in the cytosol or tethered to an organelle, until the next job.